Imagine if the human race discovered the secret to harness the power of time and space, to eliminate the vast distance between stars and galaxies and erase the limits imposed by time, to create a manufactured hole in the fabric of space-time that allows humanity to emerge in seconds on the other side of the Milky Way galaxy or anywhere else in our universe. To most science fiction enthusiasts, this is the essence of wormholes, shortcuts through the fabric of space-time itself, cosmic loopholes that flip their nose to the absolute and unbreakable limit of light speed. But the irony is, wormholes are more than just fantasy and science fiction. They emerge naturally from Einstein's equations. The math says that they are possible and they can exist under certain extraordinary conditions. The deeper question, the one that haunts the minds of theoretical physicists, is whether the universe will ever allow us to use them. In the movie Interstellar, the wormhole is shown as a neat, spherical bubble floating near Saturn, stable and safe, ideal for a spaceship to enter and pass through it, as if it were a car driving through a tunnel. It makes for great sci-fi visuals and storytelling, but in reality, it's pure fantasy. A real wormhole wouldn't just float around quietly in space. It would spew deadly radiation, tear apart anything that ventured too close to it, and collapse the instant any matter tried passing through it. Interstellar portrays the wormhole as a stable cosmic gateway, almost as if it were a naturally occurring object like a planet. But physics says that kind of stability would require exotic matter, on a scale beyond imagination. And trying to get too close to the wormhole, or worse, trying to enter it, would be, well, let's take a closer look. At their simplest form, wormholes are imagined as tunnels, an entry point or a mouth, emerging into a kind of tunnel connecting 2 points within the universe, stretching across vast distances or maybe even higher dimensions, allowing you to exit through another mouth at some far-off location. In 1935, Albert Einstein and Einstein-Rosen stumbled upon a strange solution to relativity that linked two black holes together. They called it a bridge. It was a spectacular theory, but tragically unstable. The throat would collapse faster than light itself could cross it. No matter how beautiful and elegant the math, it seemed the universe was slamming the door shut before anyone could pass through. Yet the idea refused to die. Physicists began to wonder, what if you could somehow hold the tunnel open? The answer was both exhilarating and unsettling. The problem? You would need exotic matter, material with negative energy density, the opposite of everything we know. Instead of pulling with gravity, it would push, keeping the throat from collapsing shut. We see faint whispers of negative energy in quantum physics. Strange phenomenon like the Casimir effect show that even empty space can produce a pressure resembling negative energy. But to keep a wormhole stable, you would need vast amounts of it, far beyond anything nature has shown us so far. And even if you could create a wormhole, getting close to one would be nothing like driving up to a mountain tunnel in a car. The area surrounding it would be violently unstable, similar in many ways to the event horizon of a black hole. The gravity near the mouth would likely be so uneven that it would pull harder on one part of your body than another. Physicists call this the tidal force, and it's the same effect that makes the moon tug on Earth's oceans. As you approach closer to the wormhole, it would become so extreme that you'd be stretched thin like spaghetti in one direction and crushed in another, tearing your body apart into mere atoms. The temperature, it would be at insane levels. Matter falling toward the wormhole would heat up to millions of degrees, glowing with X-rays and gamma rays. If you could look inside the mouth and into the throat, it would most likely look like a furnace in space, radiating lethal energy in every direction. And the tunnel itself would be dangerously unstable. Wormholes are thought to collapse the instant anything enters them, Even a single particle of light would most likely trigger the entire wormhole structure to collapse in on itself. If not a photon of light, your spacecraft would most certainly trigger it. If that happened while you were inside, the tunnel wouldn't eject you, it would erase you completely. Similar to the Titan's submersible accident, except on a scale of billions or even trillions of times, more violent. So the environment around a wormhole would not feel like the smooth sci-fi passageway that Matthew McConaughey passed through. It would be more like a cosmic disaster, violent gravity, deadly heat and blinding radiation. The more scientists study the physics of a wormhole, the more it seems they mathematically exist, only to tempt us. But the romantic dream of traveling across the universe in a wormhole refuses to go away, because if they can exist even for an instant, then they upend everything we thought we knew about reality. They don't just connect places in space, they can connect moments in time. A stable wormhole could, in theory, let you not only travel across the stars, but into the past. And the possibility of this kind of power over time should terrify everyone. A doorway like that shreds causality itself, opening paradoxes where effects cause their own causes, where history bends in loops. Perhaps this is why quantum physics seems to destroy wormholes the moment they threaten the sanctity of the universe and space-time, as if the universe is guarding its own existence. And yet, some of the deepest thinkers in physics see something in wormholes even more profound. A radical idea has emerged that wormholes might not be rare cosmic tunnels at all, but the hidden architecture of reality itself. Some theoretical physicists suspect that when two particles are quantum entangled, they are secretly connected by a microscopic wormhole, invisible and unimaginably tiny. In this view, the geometry of space-time and the strangeness of quantum mechanics are not enemies, but two languages describing the same truth. The universe itself may be woven from countless unseen wormholes, stitching the fabric of existence together. Could a future civilization one day tame exotic matter, sculpt magnetic fields, and carve a stable passage through space-time? Or are wormholes forever destined to remain a mirage, something the math allows but the universe forbids? That's the haunting beauty of this very concept. Wormholes live at the farthest edge of our knowledge, in the twilight between physics and imagination. If they can never exist, they still teach us something profound. That the laws of nature are more flexible and more imaginative than we ever thought possible. And if, against all odds, they can be stabilized, then they would change everything. The truth is, we don't yet know whether wormholes are the future of cosmic travel or nothing more than illusions, scrawled in equations. The possibilities of just how strange our universe may be could also be the end of the human species, as we unleash powers we have no idea how to tame.